Okay, so moving on to question number 2 of Chemicals in the Home, experiment number 5, pre-lab questions. We see that we are given solid baking soda and aqueous vinegar to react with each other to form some particular products. Now, the question itself gives us one of the products, much like what we saw in question number 1, and we see that one of them that's going to form is carbonic acid, but it actually doesn't exist in solution, but decomposes to carbon dioxide gas and water. So the first thing that we have to do with our balanced chemical equation is we have to generate our reactants, and this is given to us. We see we have aqueous vinegar, okay, which is acetic acid. So we have aqueous vinegar, acetic acid has a formula HC2H3O2, and because this is an acid, we know it has to have an aqueous phase, but the question also tells us, so we have aqueous vinegar reacting with solid baking soda. Now, in order to determine what the formula for baking soda is, you will have to look back in your pre-lab reading to determine that it has a formula of NaHCO3. And again, it said that it was in the solid phase. So we have the reactants of our balanced chemical equation, but now we need to predict the products. Okay, and this is going to be very similar to what we saw in question number 1, where we did a crisscross method and we basically swapped cations with anions. So if we look at these particular problems here, these are also technically ionic compounds. So we have cations and we have anions again. So here we have cations and we also have anions. So just like what we did for the first question, we are going to switch them. Now, one of the things that might help you when switching cations and anions, doing the crisscross method, is to go through and identify what the charges are in the original compounds of your cations and anions. So if we do that for the acetic acid, we see that in the acetic acid, we know that because this has an overall charge equal to 0, that the hydrogen is going to have a +1 charge, and the acetate is going to have a -1 charge. If we look at the next compound, we know overall it has to have a charge equal to 0, and we know sodium is +1. Therefore, we know that the anion has to be -1. Okay, so this is going to be useful when we predict our products. So we want to go through and we want to crisscross them. So I would like to take cation number 1, the hydrogen, and add it to anion number 2. So we have our hydrogen, which is cation number 1, has a +1 charge, and we have our anion number 2, which has a -1 charge. So we want to make sure that our formula is properly balanced. We do another crisscross where we take the number, and this becomes the new subscript of our compound. So we see that we get H1, then we have HCO3-1. Now, remember that when we have 1 as a subscript, that it is omitted because it is understood to be there. So this would then become HCO3. And since we have this, we know that we combine it to form H2CO3. So if we look at this, we see that we have H2CO3, which is the carbonic acid that the question was telling us about that forms. Now, ordinarily, this would be a product that we would write on the right-hand side of the reaction. However, the problem tells us that this does not exist in solution. It actually decomposes to carbon dioxide, CO2 gas, and H2O. So this breaks down, decomposes, so we know that we can write those two things as 2 of our products. Now the second part is we have to compare cation number 2 with anion number 1. So if we take a look at those, we have cation number 2, we have Na+1, and we have the acetate C2H3O2, and it is -1. So we do the crisscross method to ensure that our formula is balanced. We take the number, and these then become the new subscripts of our cation and anion. So we would have Na1, and we would have our acetate as 1 as well. And again, we know that the 1 is omitted because it is understood to be there. So our other product is now sodium acetate. So we have sodium acetate as our third product. And with sodium acetate, we are going to have to determine what the phase of this product is. So if we look at our solubility rules, we see that sodium acetate is given an aqueous phase. Okay, so we have determined what our products are based on what our starting materials were. The last thing we have to do is balance our chemical reaction. And when we go through and balance, we see that everything is balanced by mass. We have 1 sodium on each side. We have 2 or 3 carbons on each side. The oxygens are balanced. The hydrogens are balanced. So this is our balanced chemical equation. So we have our balanced chemical equation. Obviously with the products, we want to make sure that we highlight those. We see that we have carbon dioxide, we have H2O, and we have sodium acetate, which is in the aqueous phase, as our 3 products. Now in terms of predicting experimental observations, if we look at water and we look at sodium acetate, these 2 things we're not going to be able to essentially see, if you will, in solution. The only thing that we might be able to see is the carbon dioxide gas because it's coming off as a gas. So in terms of experimental observations, what we're going to see is carbon dioxide gas being evolved. And carbon dioxide gas is actually colorless.